So we're looking at practical versus statistical significance, and we've run through a number of examples and homework problems and quizzes and whatnot on inference, and we have alphas that we can reject at 0.05, 0.01. So if p is less than alpha, we're going to reject, and that's good evidence that there is something significant, there's an effect present, that there's just some reason that HO isn't really going to be for us, that there's evidence to reject it. So there's good evidence of an effect, but the effect might be small. So that's what we're talking about when we're talking about statistical significance and practical significance. Statistical significance is just what the numbers are telling us, what the likelihood of seeing a sample outcome, that much or more, given that HO is true. But the difference between HO and HA as far as numbers go might not be that important in the real world. So that's your practical significance. Okay, what we've got is an effect that we see when we have large samples present. And by large samples, I'm not talking about n is greater than or equal to 30 or anything like that. We're talking about things that are just crazy big. 5,000, n is 10,000, 15,000, really, really big samples. When you get large samples, then, you get an amplification of when things become significant. So even tiny deviations from HO may show up mathematically to be significant. So statistically significant does not always mean practically significant. So the numbers may tell you to reject, but your mind may look at what you've got for HO and HA and say, if I'm rejecting HO and thinking maybe HA is what's real, and those two numbers are too close together to matter, then what's the point in rejecting it? So when an outcome is practically significant, it means that the outcome matters in real life. It just doesn't matter mathematically, it matters in the real world. So here's an example. A lot of you can relate to this. You either have taken the SAT, ACT, or you're going to. So let's just say SAT math scores very normally. Mu is 475, sigma is 100. I know this isn't proportions, but I do have an example with proportions, so just kind of accept this for the moment. We're going to start means next week. So average for the nation or for all the population of people who have taken this is 475. But you're in an SAT prep class and the average for them is 478. So we're going to look to see if that's a meaningful change. If you look at it and you think what you may have paid for this SAT prep class, if it's $200, $300, $400 and you're seeing an average increase of 3 points over the national average, that's not much. That's not a big return on the investment. So we're going to check p-values for samples of size 100, that's big. Samples of size 1,000, that's bigger. And this one is really big, 10,000. And here are the two alternatives. Okay, so we're going to, at least in our minds, pick an alpha of 0.05 so we can, kind of look at where we might reject or not. And here are the results. So here's a sample of size 100. And, here's what the class is averaging. Here's what the overall average is for all test takers. And we're getting a p-value of 0.3821, which is pretty big. Right? So we're seeing a sample outcome at 478 or higher about 38% of the time. Our cutoff is 0.05. We're going to fail to reject. At 1,000, that's a bigger sample size. The p-value has gone down, but it's still, we would see 478 or more about 17% of the time. This is way bigger than alpha. We're going to fail to reject. But at 10,000, yeah, here we go. Seeing a difference of 3 points like that in a sample size of 10,000 is pretty rare, right? It's below 1%. It's a little over 1 in 1,000 samples. So we would reject here, but we've still got the fact that these two things are only 3 points apart, even though we're rejecting. But you're seeing the amplification based on sample size, and basically what's going on here is that your sampling distribution for 10 samples of size 10,000 is so pencil thin that there's almost no room in the tail. So 478 would be out in a tail, and it's very unlikely to happen. In other words, the tails have pulled in so close to 478 that it's just not likely to happen. All right, so this is the homework, and let's go ahead and I'm going to shift to a packet example. This was on page 15. That's not it. And this was that problem with the U.S. Department of Education, and we're trying to see if males and females have a similar graduation rate, or if they're different, right? So we ended up getting this as our p-value. Remember, we opted to just go with 0 because it was some number times 10 to the negative 13. It was so small it wasn't even worth writing, and we rejected. Okay, yeah, but if you go back up here and look at this check for normality of your sampling distribution, the female sample size was 12,678, and the male sample size was 12,460. Those are crazy big samples, and we may be seeing this amplification effect. So what I thought I would do would be to drop the sample sizes down from these big numbers down to 100, right? And I just went ahead and said p hat was 0.88, and for this p hat it was 0.85, just to get a little bit easier. So let's see what happens when we run that test. So let's go to Menu and Statistics and Stat Tests and 2-prop z-test. I'm going to warn you, I've been having some technical issues with this, so this is live TV, and who knows. So the females, remember that was 0.881, that would be 88 out of 100. And I think 100 is a fairly substantial sample size. And then we had 0.849, that would make 85, again, out of 100 for the guys. Oh, that's too much. Okay. We had an alternative of not equal to, so we're going to leave it like that. And I hope this doesn't default to a confidence interval. That's my technical issue. So let's keep our fingers crossed and hit enter. Okay, everything worked out. Remember that p-value was something times 10 to the negative 13 with those giant sample sizes? Well, look at it now, right? 0.53475. Compare that to an alpha of 0.05. We are not going to reject, all right? So we're seeing this test really not seeing any difference between 88% and 85%. That's only 3 percentage points different. It's just that when you get a big sample size, there's so much more accuracy in both samples that the test is going to believe that they're different. But when you knock it down to something more manageable, the test is going to say, man, not really all that different. So there's your practical versus statistical significance. All right? And so what else did we do? We stopped and we worked on this practice FRQ. The kids worked on it and they turned it in for a seat work grade. So you're welcome to print this out. It's on Canvas, and it's going to be in that new area. If you just kind of scroll past where the proportions are, I set up an area for AP review, and if you go there, it should be listed under reprints, and you can just print it out and do it. These are short variety questions, like 13 minutes apiece, so it should only take about 26 minutes, and that way you can earn your seat work credit. If you'd rather not do it, then I'm just going to no count it for you not being there. It's not my way of letting you get off easy, but you've probably got enough on your plate getting caught up with your other classes. But anyway, print it out if you want to do it and turn it into me on Monday. We're going to return the quiz on Monday, so stand by for that. They were a lot better than the first go around, trust me. So, okay, on that note, I keep thinking maybe there was something else, but I don't think so. So we're going to close out, and I will see you on Monday.